Okay, so from this section, this is the part where I started integrating machine learning models into the application. So the main aim of these Python notebooks is to try and experiment and try to see which model can give me the best result. So the data frame that I got is from Kaggle. It shows me information of the user, right, and determines whether the user qualifies for a loan or not. So as we can look from this example, we can see the educational, so the education of the user. We can see whether the user is self-employed or not. We can see the income, and as we go along, we can see where the user is situated, and then we can see the loan status. So what I started doing was kind of like working on pre-processing the data, try to deal with all the missing values, try to get rid of the missing values. Secondly, I started encoding the dummy variables so that our machine learning models can understand what type of data we're working with. Then after that, I started separating the features and the labels as I continue. And then from this part, I started implementing the model. So the first model that I started implementing was decision tree classifier. Started building the model. After that, started seeing how it performed. So from this one, it performed really badly compared to the other models. So the second model that I implemented was a random forest. And as you can see from the test score, it performed better than the previous model. And the other model that I implemented was a logistic regression model. So the logistic regression model kind of performed similarly to the random forest. So moving forward, I wanted to implement a deep learning model. So I implemented that model in a different Python notebook, since it requires different pre-processing steps. So as we can see, we started off with the missing values. We started looking at how many yeses and nos we have in our data set. Then we started encoding those values, and then we implemented smart analysis, started scaling, and then from that point on build a sequential neural network. So based on our performance, this model performed higher compared to the other models. As we can see, it gives us an accuracy of 0.93 and a loss of 0.17. So based on this testing, based on this testing, I would really want to use a deep neural network moving forward.